You've probably used one today. A pan that lets eggs slide across the surface like they're floating on air. No sticking, no scraping, no burnt residue glued to the bottom. It feels effortless. Almost too effortless. Because cooking by nature is messy. Food sticks, proteins bond, sugars caramelize and cling to metal. That's what heat does. So how does a smooth black surface completely change the rules? How does it stop food from attaching itself, even under high temperatures? For decades, non-stick pans have promised convenience. Less oil, less cleaning, less frustration, and they've delivered. But behind that slippery surface is chemistry, engineering, and a history that most people never think about. Because the pan in your kitchen isn't just coated in something smooth. It's coated in one of the most chemically resistant materials ever created. And like many modern conveniences, it comes with trade-offs. Non-stick cookware feels simple. You buy it, you cook with it, you rinse it clean. But the surface itself is anything but simple. What we call non-stick is usually a synthetic coating applied in thin layers over metal, most commonly aluminum. The most famous version is made from a material called polytetrafluoroethylene, better known by the brand name Teflon. It was discovered by accident in the 1930s and later found to have an unusual property. Almost nothing wants to stick to it. Not water, not oil, not food. Over time, manufacturers began applying this material to frying pans, baking trays, and cookware of every shape and size. Today, there are also ceramic-based coatings marketed as alternatives, each promising the same thing: effortless release. But whether it's traditional PTFE or modern ceramic blends, the goal is identical: create a barrier between your food and the metal beneath it. So how does it actually work? Why doesn't food stick? The answer comes down to chemistry and something called surface energy. When you cook on stainless steel or cast iron, the surface has microscopic imperfections. Tiny pores and rough spots where proteins and sugars can latch on as they heat up. As food cooks, its molecules form bonds with the metal, which is why flipping a pancake too early can tear it apart. Non-stick coatings change that interaction completely. Materials like PTFE have extremely low surface energy, which means other molecules don't easily bond to them. Instead of gripping the surface, the food sits on top of it. Even as heat causes chemical reactions inside the food, the coating resists forming attachments. On a molecular level, PTFE is made of long chains of carbon atoms surrounded by fluorine atoms, creating an incredibly stable, slippery structure. It's one of the lowest friction solids ever created. That's why food slides instead of sticking, not because it's greasy, but because the surface itself resists connection. That slippery resistance is what makes non-stick pans so appealing in everyday cooking. Delicate foods like eggs, fish, or pancakes can be flipped without tearing apart. You don't need to flood the pan with oil just to prevent sticking. A small amount of butter, or sometimes none at all, is enough. For people trying to cook lighter meals, that can make a difference. And for beginners, it removes one of the most frustrating parts of learning to cook: scraping burnt food off the bottom of a pan. Non-stick surfaces are forgiving. They reduce the chance of over-browning. They make timing less stressful. Instead of worrying about food welding itself to metal, you can focus on heat, seasoning, and flavor. That simplicity is a big reason non-stick cookware became so popular in homes around the world. It lowers the barrier to entry. It makes cooking feel easier, more controlled, more predictable. And for many people, that convenience is hard to give up. Cleaning is another reason non-stick took over kitchens so quickly. After cooking, you don't face a crusted layer of stuck-on residue that needs soaking or scrubbing. Most of the time, a soft sponge and warm water are enough. The same low surface energy that prevents food from sticking during cooking also prevents burnt sugars and proteins from bonding permanently to the pan. That means less time at the sink and less force applied to the surface. For busy households, that matters. Fewer abrasive cleaners, no steel wool, no chiseling away at stubborn bits. Compared to cast iron that needs careful seasoning or stainless steel that demands technique, non-stick feels low maintenance. It fits modern lifestyles where speed and convenience are priorities. Cook, rinse, done. That simplicity helped turn coated pans from a novelty into a default choice in many kitchens. But convenience always comes with conditions, and a non-stick is no exception. One of the biggest limitations of non-stick cookware is heat. While the coating performs beautifully at moderate temperatures, it has boundaries. Traditional PTFE coatings begin to degrade when heated above roughly 260 degrees Celsius, or about 500 degrees Fahrenheit. At those temperatures, the material can start breaking down and releasing fumes. Under normal cooking conditions, especially at low to medium heat, this isn't a problem. But empty pans left on high heat or high temperature searing can push the surface beyond its limits. Professional chefs often prefer stainless steel or cast iron for intense browning because they can tolerate far higher temperatures without risk of damage. Non-stick by design is optimized for control and gentler cooking. Push it too far, and its performance and longevity begin to decline. It's not fragile, but it isn't indestructible either. And understanding that boundary is key to using it safely and effectively. Heat isn't the only vulnerability. Over time, non-stick coatings wear down. Metal utensils can scratch the surface. Abrasive sponges can thin the protective layer. Even stacking pans without protection can create small cuts that grow with repeated use. Once the coating is damaged, its performance changes. Food may begin to stick in patches. The smooth glide becomes uneven. In some cases, flakes of the coating can peel away. While small scratches don't instantly make a pan dangerous, they do shorten its lifespan. Unlike cast iron, which can last generations, most non-stick pans are designed for years, not decades, of use. That built-in wear is part of the trade-off. You gain convenience and ease, but you sacrifice durability. It's a surface engineered for performance, not permanence. And the way you treat it, the utensils you use, the heat you apply, how you clean and store it, determines how long that performance lasts. Beyond durability, there's another concern that often comes up: safety and environmental impact. Older non-stick coatings were manufactured using a chemical called PFOA, which has since been phased out in many countries due to health concerns. Modern PTFE cookware is typically labeled PFOA-free, and under normal cooking conditions, it's considered safe by major health authorities. The key phrase, though, is normal cooking conditions. When severely overheated, PTFE can release fumes that may cause temporary flu-like symptoms in humans and can be harmful to birds. There's also broader discussion around PFAS, a group of so-called forever chemicals used in many industrial applications because they resist breaking down in the environment. While the amounts associated with finished cookware are tightly regulated, public awareness has grown. Add to that concerns about microplastics from worn coatings, and it's easy to see why the topic sparks debate. Non-stick isn't simply a kitchen tool anymore. It's part of a larger conversation about modern materials and long-term impact. So, should you use non-stick cookware? The answer isn't as simple as yes or no. Non-stick coatings offer real advantages: effortless cooking, easier cleaning, lower oil usage, and accessibility for beginners. They solve everyday problems in practical ways, but they also require care, moderate heat, gentle utensils, replacement after years of wear. They aren't built for extreme searing or lifetime durability. Like many modern technologies, they represent a trade-off between convenience and longevity. Understanding those trade-offs changes how you see the pan in your kitchen. It's not magic. It's chemistry and engineering working together within limits. And when you know those limits, you can decide how and when to use it. Because sometimes the most ordinary tools tell the most interesting stories, especially when you look beneath the surface. If you enjoyed breaking down the science behind something as ordinary as a frying pan, there's a lot more hiding in plain sight around us. Everyday objects are often built on decades of research, unexpected discoveries, and quiet engineering compromises. We use them without thinking, until we stop and ask how they really work. If you'd like to see more videos exploring the hidden science behind common technology, consider subscribing. There's always another layer beneath the surface, and sometimes the simplest tools reveal the most complex stories.